Hi everyone, I'm Mahesh. I'm a data scientist at Ticketmaster. We have with here Dave Johnson sitting in the first row. Feel free to reach out to him to know more about technology-driven marketing initiatives at Ticketmaster, either in SEM space or SEO space. Also, if you have some queries around the dynamic pricing initiative, feel free to reach out to him. So today I'd be talking about our journey while embarking on building this contextual real-time bidding engine for search engine marketing. Moving on. So I'm part of the customer acquisition and analytics team. 1 year ago, this team is non-existent at Ticketmaster, and we have made some pretty good progress from that point. Broadly, it consists of ad ops teams who on a day-to-day basis make the bidding adjustments for our campaigns, business development teams who give us the broad requirements, and technical teams who realize the potential of these requirements, who translate this to actual infrastructure. So broadly, our mission is to match fans to events they love by highlighting popular events in their area through search and social marketing. And moving on to the aspect on how we actually do it. So just imagine someone searching for Bruno Mars tickets on marketing platforms such as Google. So there are a bunch of ads which are shown at the top and followed by some organic links. So at the moment, our infrastructure powers these ad links. So it's completely created, and the whole pipeline of creating them is powered by our infrastructure. And we are just beginning to put out automation in the SEO space, like looking at the audit logs and trying to figure out some new keywords in the SEO space where people are actually searching for, trying to create some sense of fan-centric keywords for the live events. So we made some pretty good progress on SEM side, and we are just beginning on SEO side with respect to automation. So if we question about what our infrastructure powers, it's basically we power the intent-based event discovery on marketing channels. Intent of a fan or a user can be captured by various ways. For step one in our current iteration, it's captured through keywords. So just looking at SEM, one of the broad SEM cycle on the top right. So the first three parts, like keyword research, common analysis, and ad copy creation, the product teams help us in this aspect. And the fourth step, where our first component comes in, the campaign creation module, which just automates campaign creation on all marketing platforms. And on the fifth step, which we are making our current iteration on, how to automate the optimization of these campaigns, on trying to build some infrastructure for it. If we are looking at one specific campaign, so all the aspects like campaign creation, conservative bidding, gathering data, optimization for optimal bid placements. We have been doing this through some third-party tools over the last year, and we are constantly decreasing our spend number to achieve the same amount of revenue. So at some stage, if let's say we spend $50 to get $100 revenue, we are constantly saying probably it's like $30 is a success. After a few months, probably after some more months, we are saying $20 is our next bet, something like that. So we are decreasing our spend to attain the same revenue, and we have quite some significant success in that area. Now we are trying to see if we can stay in that loop and get even more efficiency with some automated systems. And that's where our continuous optimization system kicks in. So further talking about what we do from broad high-level architecture perspective, like architectural diagram of our tech infrastructure. So we have a pretty good idea about events, artists, and inventory. We know upfront like what are the artist tours or which are further planned like 1 year, 2 years down the line. All this data comes into our central data warehouse. And some aspect of this data is provided to the campaign creation module to create the campaigns or marketing platforms, and there's a continuous feedback loop between the marketing platform and our optimization platform. So we literally, in our current scenario, we pull the data from performance data from the marketing platform hourly, and we try to optimize on that. Our emphasis for the last year has been more around automation, optimization, and data. First, our campaign automation module has decreased the grunt work of building marketing campaigns. We got one heck of improvement in terms of scalability with the campaign creation module. Then third-party tools let us optimize our spend to some extent. And we have our own custom pipeline Spark scripts to give us a better sense about margins around all this keyword bidding in the SEM space. Currently, we are trying to automate the optimization part, leveraging the data we have. So from a technology perspective, we moved from manual bidding and manual campaign creation to automation and now we are in the pipeline of moving to this autonomous bidding agent, where we envision this as something which knows how to really bid the optimal amount for each keyword. And thinking about like how this translates to business priorities, we believe that regardless of whether an event is a popular event or a new event, there always exists some audience for that event. So our infrastructure matches audience to the new events, and also we have a sense of fanness of all the users coming into our system. From SEO space, we can gather fan-centric keywords, and then we can start automate bidding on those keywords, which help us match fans to the live events. So our technology powers these two things, and these two things broadly meet the business goals of more sales, more revenue paradigm. So one specific business use case powered by our technology, we have most of this automated, and we are further automating some of the front-end components to it at the moment. So imagine some of the teams within the Ticketmaster give us some capital to operate upon. So the capital flows into the campaign creation modules, which creates campaigns on marketing platforms, which sets the hard limits of budget constraints, and optimization platform through its feedback cycle improves upon that. So this is more around other teams within powering other teams within Ticketmaster with our infrastructure, both in terms of scalability and reducing the time perspective for creating campaigns. Or it could, we are also providing API support to our campaign creation modules, which can be integrated into other front-end tools within Ticketmaster, who with just a few clicks can power campaign creation and optimization on that. But to get this loop going, we really need to get the optimization right. So broadly, like we want to have optimal revenue, higher revenues at optimal spend. So what does this all translate to when we are talking about SEM bidding space? So initially, like our optimization platform sets a bid price, but the final bid price, which is set on the marketing platform, is like a function of our bid price, the audience-based modifiers, and bid modifiers specific to a device or geolocation or some other aspects. So if you are just looking at spend perspective, the spend is a function of bid price and quality scores, which is internal to each of the marketing platform. Broadly, the higher the quality score, the lower prices we pay for even the better ad positions. Quality scores is one thing which we cannot control, but it's something internal to the marketing platform and has some SEO strategies around that. So talking from a revenue perspective, our revenue is broadly a function of inventory and price. So if our goal is just to optimize for spend, one way is not to spend at all, which is not a marketing paradigm. We constantly want to spend a certain amount to gather more audience, but drive convertible traffic at the chosen spend levels. All these functions over here, like we can throw in different machine learning models to model these functions, neglecting the quality score part, but it all depends upon what the business requirement is on how important it is to model any specific component of it. So further down, like I'll be broadly talking about our actual engine, which updates the keyword bids. Broadly, it's divided into like the two segments to it. One is the distributed real-time infrastructure, which powers the whole bidding process, and the offline modeling pipeline. The asterisk over there indicates what we really want to do is an online learning pipeline, where we continuously pull the data, update our keyword bids. But prior to going there, we want to prove some efficiency with our modeling pipeline. We want to make sure that the data flowing in is right, the model is doing the right thing, and business and product members are happy with our updated bids. So first, we are trying to get the offline modeling right, and our next step would be to get the online modeling right. So broadly, from an infrastructure perspective, like on the distributed real-time pipeline side, I will be talking about our architecture, our technology stack, and our broad monitoring pipeline. And on the offline modeling side, I'll be giving you some general idea about contextual bandit, the model we actually use, and the explore exploit strategy, some of the modeling challenges we faced, and how to evaluate the contextual bandit models, which is a bit different from any other supervised learning models, and our technology stack on that side of modeling side. Broadly, like this real-time infrastructure and the modeling side helps us do two things really well. One is the contextual keyword bidding, where we are moving to. All we had is like some minor success, but we are moving further down that line, and applying business rules in real time, which is in production right now. So like any of the product team members could affect the business rules. Like some of them could have been like activate campaigns which have certain predefined, which meet certain sell-through rates or inventory limits or something like that. We already realized that, and our infrastructure is moving us further down into applying machine learning on top of our data. So these are distributed infrastructure. I have like very few slides describing it, but there's a lot more work which went into it in coming out with this version. Like there are many iterations around this and many more technological choices at different points. So broadly, like what we follow is called a blackboard design, wherein all the features on the far left will write the data to our central store, which is like HBase right now. And all the downstream aggregators can read the data of our central store and update the bits on marketing platform. It could be an AdWords bid predictor reading off keyword data from our central store and updating AdWords bids, or it could be which is what we are working on currently, but it could as well be a bid predictor for Facebook or Bing, which reads its own marketable entity from our central store. Keyword need not be the marketable item across all different marketing platforms. So we call it marketable item, the entity that can be marketed on a marketable platform, which is AdWords, which is keyword for AdWords platform, which is some notion of catalog for Facebook and other things. So broadly, like fetchers write the data to central store. The data is polled by the bid predictor from the central store. The context comes into the bid predictor. Bid predictor makes an action, which is a bid price. Let's assume for a moment that the reward data is directly available to the bid predictor. The reward data being whenever you execute an action on a bid word, people might convert or might not convert. When they click through that link, add link, you could treat this as a reward signal. If you assume that the reward is directly available in bid predictor, what bid predictor is logging to that reward topic is context, action, and reward. So this dataset is like really helpful, which I'll get into shortly down the line. But this infrastructure is helping us to log context, action, and reward data. The ideal pipeline we want to go into is reading off the data from an online learner and validating, having some basic validator around if the model is ready to be swapped, and swapping out the model on the bid predictor side. But the thing we are trying to get right at the moment is more about the offline learner. All the data which goes into our reward Kafka topic also gets backed up in S3, and our offline learner reads data off the S3, and currently we're in the process of doing some model validation around that. And first we would be swapping out the models with the offline learner, and once we have some significant results, we would be shifting the pipeline to online learner where the models are swapped more often. So just going to the future of this architecture, we don't have automation around keyword mining, but we just began to put in some automation in the keyword mining in the SEO space, which will help us realize more important keywords. And our senior architect realized most of this platform, and he intends to move this to the sentiment-based marketing model, wherein a positive sentiment about something on social media could trigger sales for a specific live event. So we want to drive that, but that would involve bringing in data from other social media platforms and so forth. So this architecture puts us in a good position to move there, and currently we are trying to extract the value of it with our current context, which is campaign events, sales information, event metadata, and campaign level performance. Talking about the real-time technology stack, broadly we use Storm for real-time pipelines, HBase as our central store, Vowpal Wabbit as our contextual bandit learner. I'll get into why we happen to choose Vowpal Wabbit. And we use Kafka for our messaging layer. All our Kafka data is backed in S3, so we have permanent storage aspect to that. And we use a whole fleet of Amazon Web Services. Hive is basically to read in the S3. We use Avro data format to dump data to S3, and Hive is helps us to read in a lot of Avro data. We can dump our Avro data in HDFS and put up a Hive table on top of that. It helps us to inspect our data at different points in time. The reason for using Docker is VW, our machine learning prediction library, has its own dependencies, library dependencies, to encapsulate which we went with the Docker store, and we use the ELK stack, Elastic Logstash Kibana, for monitoring and visualization purpose. One point which I forgot to mention. So previously I was saying something like the context comes into the bid predictor makes an action on marketing platform and dumps context action reward data to the reward topic. The thing over here is the moment you set a bid price on a keyword, it takes a while for it to percolate through marketing channels and for people to come in and convert on those links. So you need to give it some time slot to actually call it off as success or failure, to know that whether the new action is a success or a failure scenario. So from the bid predictor to the marketable item side, you see a red arrow at the bottom, which is more like bid predictor also logs its context and action to our central store. So in the next run, whenever we get the sales information for the same exact keyword, the sales information would contain the reward data. So the context coming into the bid predictor has also the previous context, which also has previous action for the same keyword. It merges the previous context, previous action with the current reward and dumps out the context action reward data point. I'll get into the value of this single data point shortly. So our monitoring pipeline is our Storm logs to Kafka, and we have a setup wherein Logstash moves the Kafka data to Elasticsearch, where indexes are built on top of that, and Elasticsearch has its own index mechanism, and it's easy to search data on it. We throw in Kibana dashboard at the top to have better visualization platform. So broadly, what is this platform? What is the benefit of this platform from a business standpoint? So we have two aspects. One is optimization rules and keyword bidding. Optimization rules is more about product driven. It can be articulated as simple rules and can be applied by our system in real time. Keyword bidding, as I was talking about a few slides back, is a function of various different components. It's difficult to articulate it as a single rule. It's more of machine learning driven for now, and we could have an explanation service at some point to better explain about its bidding strategies. So currently, on a rules side, the pausing and pausing of campaigns is done in real time with respect to inventory limits, sell-through rate limits, and also the whole system provides some knobs to help business people tinker with it. More importantly, to tinker with it in real time. Also, the reporting is made available through Kibana dashboards, so the system is well set up. So any of the machine learning deployment pipeline, you have a whole series of things around the model pipeline. Modeling is one important aspect of it, but getting the data right, getting the architecture right, logging, monitoring, reporting, all these aspects do count in. So we got that right at the moment. Moving on to the modeling pipeline. So this is actually our journey towards the online learning pipeline. So there exists different forms of learning from a machine learning perspective. One of them being unsupervised learning, where you just have the features and no label. Think of it like k-means clustering or any other form of clustering. There could exist some semi-supervised learning mechanisms wherein you have some features and you have some discrete label or some real value label, and the labels might be missing. But for some example, this is one form of learning. Then the most popular form of learning is a supervised learning, wherein you have features and you have a label. The label could be a discrete number or a real value, or it could be a structured object like a tree prediction or something like that. But what we are using broadly falls into contextual bandit paradigm, which is a kind of reinforcement learning problem. So in reinforcement learning has, on top of context and label, it has something like context, action, and reward for that action. I'm going to shortly be explaining on how we exploit that. Reinforcement learning is more about sequential decision making to get the highest cumulative reward over time. The reward could be anything. You could maximize for clicks, conversions. It's user defined. In the current era of deep learning on a parallel track, there is no industry standard deep reinforcement learning applications yet. So we rely, talking about the contextual bandit explicitly, for each action, there's a single reward associated with that, which is not usually the case with the reinforcement learning problem. Imagine a robot lifting a ball from the ground. There are multiple actions which come into play, but some actions might succeed, fail, but the eventual reward is defined as a success scenario when the robot lifts the object. So you don't have an association of single action to reward mapping in that scenario. And in reinforcement learning, you end up modeling the state transitions across time. In contextual bandit, there's nothing of that sort. It's more about an evaluative mechanism than a learning mechanism. It's more like, for this action, we have certain reward, and what is the next best action in this scenario? Not really to bother about all the history. We want to drift with drifting distributions with time and not really bother about the historical data, but as well, we want to generalize some aspects pertaining to context. Just to emphasize the same point, like in the live event space, we always see this, like an event goes on sale, we have a primary sales peak where a lot of people purchase primary tickets, then sales cycle remains constant for a while, and then there's a resale peak where the resale tickets go on sale. So there's some dynamic aspect to the sales component in the ticketing industry at large, and we want our context to capture that part. Moving on to the contextual bandit overview. Think about like you have a slot machine and you get some reward while pulling each arm. This is a typical multi-arm bandit scenario, and if you assuming your reward distribution for each action is constant, if you just observe some people pulling in different slots, you can notice over time that maybe slot 2 gives you the highest reward or slot 4 gives you the highest reward, and you can capitalize on which action to pick. But context does help if reward distribution is not constant, and if it's something like the morning time slot 1 gives you the highest reward and in the afternoon time slot 2 gives you the highest reward. This is the context which is driving you to make the choice of which action to pick. So context is the key in contextual bandit scenario. In the SEM space, someone searching for Bruno Mars ticket, it's more likely to show him a Bruno Mars specific ad than other ads. So context help us bid the appropriate price and also give him the appropriate link. So being more explicit about SEM use case, the user searches online for tickets with some query keyword, and user sees a link, but under the hood, optimization engine was bidding certain amount for the keyword, and user responds to that, the purchase or no purchase. The 3 steps can be captured as something like context, action, and reward. Another data point. Eventually, like Ticketmaster wants us to choose a policy for spitting out the appropriate bid price for each keyword, targeting different live events at any given point of time. So broadly, like as I was speaking, like context is really the most important factor in the contextual bandit mode. And what contexts are we capturing at the moment? So this is not an exhaustive list, but roughly on the advert side, we have keyword performances, we have event inventory. These two are more of give us a sense of supply and demand information, and we have conversion information, event metadata, aggregate performance and sales information from our data warehouses. Keyword context gives us a sense of what all has happened in the history, but user interaction determines where the things are drifting right now. So user interaction with our ads gives us a sense of what are the currently more popular keywords, what is the current demand for event artists at this point of time. So the drifting component is captured by the user interaction, which sends us a signal back to shift our distributions. So the drifting distributions is a prominent use case for the online learning. So contextual bandit is more about which arm to pick in a slot machine, or it's more about which action to choose when you have a set of competing actions. That alone is not sufficient, because you might be bidding some $2 for a keyword, but as the event progresses, there's very limited inventory at some point in time, at which point you should not be probably bidding that high. Maybe you should just bid some small amount because of lack of good seats. So to capture that, we need to have a mechanism to drift with respect to user interactions. And explore exploit is a strategy which gets us to that point. Exploitation is more about making the best decision given current information. And exploration is more about taking a random action at a time step just to see if the distribution has drifted to some other action. So ideally, like best long-term strategy may involve short-term sacrifices. So if you exploit all the time, there are many papers written around this point, popularly by John Langford, who is at Microsoft right now, that exploitation all the time doesn't lead you to the optimal goal, but exploit well. If you know upfront that the reward distribution is pretty constant, there's no point exploring there's no point exploring to see if there's other better action. But if you know that the reward distribution drifts, there's value in exploration. So it could be as simple as that. In your prediction pipeline, in our bid predictor, for each context which comes in, epsilon value is usually like 0.2, 0.1, small number. With a very high probability, like let's say epsilon is 0.2, with 1 minus epsilon, with 80% probability it picks the best arm. It chooses the best bid price for keyword at a given point of time. But with some 20% probability, it goes in a random exploration mode, wherein it chooses any bid price for a given keyword. This is both good and bad. Good for exploring if the keyword demand has drifted, if we should be bidding higher or lower, maybe our position has dropped, maybe new resale tickets have come live in our inventory database. So it could be for a number of reasons. Exploration is good, but the reason is if it's bad is like if you have certain range, if you have a minimum to maximum value of bidding range, your random exploration could bid higher on average. So there are ways to restrict the exploration space for an event. And yeah, it's more about figuring out the drifting distributions and drifting patterns at which you need to put arm. And when I'm saying that with 80% of the time you're choosing the best arm, this is context dependent too. So for one keyword targeting some specific event, maybe if it's based on its match category, whether it's a broad match category or narrow match category, you bid differently. So the best arm is context specific, and it's not you don't bid the same amount to all the keywords. It's all a game of context. So just to explain you further about some real world scenarios for explore exploit. So choosing a good restaurant for dining, you might just pick one restaurant which you know serves the food of your taste, or you might explore a new one. Clinical decision making, the doctor could give out a valid, well-proven prescription, or he might try something different. But the exploration should not, the random exploration in clinical decision making could be fatal, as the patient health is at risk. So in some sense, the exploration space is limited on trying variants around that. Ad ops team making bid decisions, they tinker with different bidding strategies for keyword, and whichever works best, they go with that. And There's a HyperOpt package, which is more about parameter tuning for machine learning models. It was first published by a Harvard postdoc, and later on it made its way to all the scikit-learn, VW, and all other machine learning packages. The basic idea behind it is, rather than doing grid search across your parameters, you could do explore exploit on your parameter space. You could sample a few points in your grid search space, and you could further sample more points around the more promising parameters rather than tinkering with all the different different uniformly spread parameters. And choosing the banner article of a home page, or personalization systems at large skew your world, whether it's be news article recommendation or something else. If you need some diversity in your personalization system, be it personalized voice assistant or personalized search display, you could have add exploration aspect to it to give you some diversity. Standard A/B testing paradigm, and Microsoft has contextual bandit as service called MWT service, which follows the explore exploit paradigm. So broadly, so as is being previously, it's all about in the MWT cyclic learning loop. The third point is you deploy a model which does both exploration and exploitation. Exploitation is more about choosing the best action right now. Exploration is to know more about the drifting actions. The logging is, so you first deploy, explore, do some 20% exploration during your deployment phase. You log all your data, you learn from your log data, and you continue. This is the online learning cyclic loop, which powers the contextual bandit online learner. So let's say you want to test some new hypothesis, like previously you deployed a model to improve your click rates. Now let's assume you want to test if conversion rate would be higher with this new model on the historical data set. On a traditional A/B testing pipeline, so on the contextual bandit side, you log context, action, reward, and probability with which action is taken. For exploration, probability would be smaller, more around 20%. Exploitation probability would be higher, more around 80%. On the A/B testing side, you just log context, action, reward. So contextual bandit is more about explore, exploit. A/B testing is explore only mode. The difference being that, let's say you're testing out some 5 variations in an A/B testing pipeline. Your input traffic is split between all those 5 variations. Maybe 2 variations are really bad and you need to phase it out, but you still let it run on the A/B testing pipeline. Just you need to give, for statistical significance, you need to give it some time to call off success, to call off whether your hypothesis is success or failure. But on the contextual bandit side, it's in the five variations you're trying out, if only 3 are really relevant, contextual bandit will just have a very low probability for the remaining 2 events, so that they'll not show up on the exploitation phase, which happens for 80% of the time. So underperforming actions are pruned out and they're not in the A/B testing pipeline. Broadly, in the contextual bandit learning phase, the equation in the second line is more about, let's say you have a historical data point, XHAR, context, history, action, and reward. The second line is a reward estimate for, so pi of x is like you have a historical data set, let's say for improving click-through rate, and now you have a new model for conversion rate, and you apply the model on that context tuple. It chooses an action, and the second line, that's the reward estimate for that action, you get the reward for it. And the first line is more about R over P is called the normalized probability. Just focusing on R over P ratio. If for a low probability event you have high reward, R over P is higher. If for a high probability event you have low reward, R over P is smaller. So it normalizes for that. When you're doing your random exploration for 20% of the time, if you know that you received highest reward for some bit price, you try to drift to that, and R over P normalizes for that. Broadly, what's happening over here is you're trying to test out a new model pi on an historical data set, captured with some other model. And the first line is more about if your new reward is higher than the reward estimate you had for that action, you try to capture the delta part of the improvement, and as your learner proceeds to online learning, you try to see how the aggregated R over P value is. If it's increasing, it's a sense of capturing that your model is doing something right. And the reason you can, for actual learning pipeline, you can further look at that paper. The reason it's modeled is, the first part is more about context to action mapping. The second part is more about action to reward mapping. In the W. Roberts paper, these two are blended in with the notion that usually it's difficult to model reward for actions. It's like completely predicting the future, but it's a bit easier to predict context to action mapping based on your context data. So for further details, you can look into the paper, but broadly these two functions are brought in to evaluate any new model on historical data set and to further reason about that, which is not at all possible with A/B testing. We have our technology stack is more about Spark, Amazon services, Hadoop, and all that. We were using initially NumPy, Anaconda platforms and all, but once our data grew to a point, Spark was the only choice. VW is really good. It has many hashing tricks to avoid feature collisions. It has scalable implementations. Everything in VW is less error prone because the underlying base classifier is always a binary classifier also. Just one thing to note about VW is your feature names are case sensitive, like the last point. It's a way to encode categorical variables, and those two are different just because of the case. And some of the modeling challenges we faced are like sparse reward scenario. Though we know that we have convertible traffic for some keywords, we want our keyword base to be large just because we want to attract more audience. And when you have that, for most of the keywords, you don't have a reward signal all the time. The way we counter that is to reward aggregates. Though we don't have a reward, let's say our system operates hourly, though we don't have a reward signal in the last hour, we compute its aggregates. We take an average of last hour, last day, last week, and the blended average. So the first sale point that ever happens on the timeline defines all these aggregates, and the blended version makes sense. VW broadly moves to a context action mapping for a context, which might lead to a higher reward. So for scale, to handle the scale, we are using Spark. And as I was speaking previously, to really see if your online learner is working smoothly, you try to inspect the R over P value, and which was a signal of a better online learner. For now, one of the kind of offline modeling pipeline we are evaluating is taking a data set and have different reward functions to it. One could be click, one could be conversion metric or something. Then have VW hyperop tune its parameters, and then figure out the model with best model loss, lowest model loss, and see if that translates to business metrics too. Currently, there are a number of things we are exploring, and contextual binder is really good at choosing a small number of actions, doing explore exploit on a small number of actions, and so we could restrict or increase our action space. We are tinkering with that. We are trying to see if some generalization could be achieved based on our context, and we are working further on the model evaluation side. So I was speaking merely on behalf of our entire team, and we have product members on the far left, AdOps team on the far right, and the tech team who has helped us to get to this point. Thank you for your time, and if you have any questions, let me know.
We have time for one or two questions if we move really quickly.
Hey, you said that you guys are moving from offline to an online solution, right? And I saw it to a Storm. I don't think Storm has enough machine learning libraries that Spark has.
True.
So are you guys evaluating your own solutions, or is there anything that you guys think can use it?
One reason for moving to Spark is because of the machine learning capability. But what we really are using is VW, Vowpal Wabbit. VW has VW JNI, Java-based interface, which can plug into Storm pipeline. So we have prediction pipeline in Storm side. But VW gives its many other metrics like probability of each arm, the loss value as the learner proceeds, which are not available on the VW Java side. So we are doing an offline learning to see if we are getting the things right.
Yeah, even in terms of storage, Are you guys planning to move something like Druid kind of a thing for real time?
Could you come again?
Druid? Apache Druid? For the data store? I can think of it.
Possibly not, because at Strata Hadoop, like I was talking with Flink guy, and our current comparison is between Storm, Trident, Flink, Beam, and so.
Last question.
Great talk. I'm excited partly because I'm from Microsoft. And so I was wondering, do you manage one campaign or multiple campaigns at the same time? If multiple campaigns, how do you manage the competition? Like if everything is based on the reward, some campaign may starve because other campaigns take all the resource.
So by company, you mean a different marketing platform, or?
Different marketing campaigns at the same time, or just one campaign once?
So, yeah. So what you're broadly asking about is having the competitive conversion information from one marketing platform available to other marketing platform as a context. How does it compare across marketing platforms? So complaints?
The campaigns are largely mutually exclusive, either from geography or different different events are behind different campaigns. So we don't have competition between the different marketing campaigns generally. There is some overlap, like you may be interested in two different Britney Spears and Bruno Mars, you may be interested in both of them. There is some natural competition internally from a fan's perspective, but the campaigns themselves are largely focused to specific events and or geographies. No, they are both being marketed at the same time, but usually the fan base is going to be focused more on one versus the other naturally. They're going to segment themselves.
All right, at this point, I want to thank everybody for joining us. I hope you enjoyed the conference. Hopefully, we'll see you back next year.